Hi guys, welcome back. So in this video, we'll be going over chapter 1.2 of O-level physics syllabus 5054. Before we start, one side note, in the previous video, I did mention I'd be going over micrometer screw gauge and how to use that. Unfortunately, I do not have this equipment on hand, and trying to make this, make it un- understood to someone else is really hard only by, I don't know, showing a picture, as you would probably need to see a live demonstration. So I'll be linking any resources I find in the description so you can understand this topic. You can just also search on YouTube to find, try to find anything better. So yeah, good luck with that. And this video will be going over chapter 1.2 of motion, forces, and energy. So we'll be again going point by point, and we'll be going in much more detail. So yeah, this is gonna take a while, but after we have finished going point by point in detail, I'll also provide a short recap from every single one of these points. So yeah, let us begin. Number one, define speed as distance traveled per unit time and define velocity as change in displacement per unit time. Okay, define speed as distance traveled. Okay, speed is distance traveled per unit time and velocity is change in displacement per unit time. And in theory, change in displacement is basically also distance traveled, but you know, slight differences. And then you might be wondering, what is velocity, what is speed, and what is displacement? And some people might be, new to these terms. So let us first, I don't know, try to think about very basics, from the very basics. Because in grade 8 or grade 7 physics, it probably didn't, it probably hasn't been taught to you. So yeah, my first example will be something about speed. So let's just say there is a big truck. So big truck, and it is going this way to the right side. And then there is a, I don't know, a small car, let's just say some kind of supercar, a race car. Sorry for this weird car, but this will have to make do. So both are, traveling to the right direction. And this car has a speed, it is going this way with the speed of 20 meters per second, and this car is going this way, and it also has 20 meters per second. So then there's a finish line here, and both of the cars start moving, and which one crosses the finish line first? Some people might think that this is a big truck, so this will, cross the finish line, so this will be your supercar, and it will obviously cross the finish line much much faster. But this is where they get this wrong, because this is the speed. And what do they mean by the speed? So they have the same speed, and that does mean that these two, this one and this one, they are traveling the same distance in 1 second. So if I give the car 5 seconds, and if I give the truck 5 seconds, they will both move 5 into 20. That would be 100 meters, right? They will both move. Let's just say this is 100 meters away, right? This is 100 meters away from here to here. So what will happen after 5 seconds? They will both cross the finish line at the same time. Remember, speed is how much you are moving each second, right? Meters per second, m/s, that would mean meters per second. And you can also write it like this, divided by, cause meters per second. But in physics, we write it this way. So remember to write it this way with a slash. So this is speed. And distance is pretty intuitive, because distance is just the distance from point A to point B. This is the distance. Now we know what distance and speed are. So distance traveled define speed as distance traveled per unit time. And we have done exactly that. Distance, which is 20 meters, per unit time, that would be seconds. Okay, define velocity as change in displacement. Now we come to what is velocity and what is displacement. So, this example won't do anymore because velocity and displacement are something very, very, new. So we'll have to go into even more basics. So first, let's start with velocity. Velocity is a vector. And for those who are wondering what a vector is, basically it has a size and a direction, or magnitude and direction. What does that mean? So consider speed. Speed is only measured in size. So speed does not have a direction. What Why does that matter, and how does that affect me? And I have an example here. So let's assume a car is going this way. So let's just assume this box is the car. So it has 20 meters speed, right? There is no sign here, no plus minus, nothing. This is just 20 meters integer. And let's just say a car is going this way. So 20 meters speed. So it only has, a size that would be 20. So 20 is the size. It is 20 meters long, or 20 speed big, whatever you might want to think. So it does not matter even if you're going upwards, you're going downwards, it does not matter. But velocity, it does matter. So how does it matter? So let's just say a car is going towards the right. Will be your car, and it has a velocity, right? Velocity 20 meters per second. So velocity 20 meters per second. So this one and this one looks the same. So what is the difference? The difference is there is a plus sign here, right? Normally in maths, you do not put a plus sign. A plus is basically invisible. It is assumed if there is no sign, it is a plus sign. And so what if you go to the opposite direction? So you go here and it becomes 20 meters per second with a negative. So now the direction matters. The direction would be right side is plus, left side is minus. Okay. So this is the difference in velocity, that it has both magnitude and slash size, right size because it is smaller, size and direction. It has both size and direction. This is the difference in velocity. And velocity, you can take this side as plus, right? You can take left side as plus if you want, right? It is up to you. If you take one side as plus, you have to take the opposite as minus, right? This side will be then minus. You must do that. You cannot take both side same sign. One side shall be plus, one side shall be minus, and that is completely up to you. The question also may specify which side they are taking as positive or plus. So do take note of the question also. And then comes a question of what if you go up? So in O levels, we will not be discussing what happens when you go to the left, let's just say, and you also something also goes to the, goes above or goes up. So we will only be getting questions of one thing is moving towards the right, and one thing. So this was the left side. So this was the left side. This is the right side. So the only questions you will be getting is one thing is moving towards the left, one thing is moving towards the right, and then some maths will be involved. So only left, right, and only up, down, right? If something is going up, something will only be going down. Only these kinds of questions are going to be included in O levels for velocity. So velocity, that is it on velocity. And then comes displacement. What is displacement? So, let's see. Sorry. DIS. Displacement. We have studied about distance before. Distance would be A, B, point A to B, 100 meters. and that does not matter, if this is carved and bended point A to D, this will then becomes, let's just say 10 meters, it will be, I don't know, 30 meters. Why? Because look at the road. Obviously, this piece of road, or let's just call it a string, this string is now longer. You have to travel much, much more as the roads are winding and bending. So 10 versus 30. But look at this. Point A and D are, let's just assume, right? Point A and D are these 2 points. They're at the same exact, far apart if you go to from a straight line. So this is what displacement is about. It does not matter what you know you are doing from A to B, right? It does not matter. Like they have asked from in the question, go from A to B. Even if you take this convoluted path and go from A to D, the displacement will always be the straight line going from A to B. So the straight line will be 10 and the distance will be 30. So distance matters. Why? Because let's just say the amount of path you traveled is the distance, and the displacement is the amount of actual ground you covered, right? So if your objective was from going from A to, let's just say, D, right? So this was your objective, and you have moved so much convoluted pathing, then you are inefficient, as it probably has taken you much more fuel, much more time to go such a long distance. If you went from a helicopter, you could have just flown in a straight line, easy. So displacement and velocity, these two. So now we'll go and take a quick look at the notes. So this is again znotes.org, a free notes website. You just have to sign up for an account and you can access the notes. So this is IGCSE notes, but it works for O level also. Keep that in mind. Now let's move on to the actual notes. This will be in the chapter 1.2. And okay, so they have provided examples for distance time graph at rest. So okay, so this one actually will come a bit later. We'll get back to that. So first, let's look at speed and velocity. Speed is the distance traveled by a body in a unit of time. As we have seen here, speed would be amount of distance in one unit of time or seconds. When the distance traveled in s over short time t, the speed is given by v equals s by t. So they have a formula for distance. So speed equals distance by time. Let's see this formula. So s, which will be speed, equals d by t. Speed equals d by t. Distance divided by time. And let's just say my speed was 40 meters per second. Let's write ms. And now let's just assume a question. Question says a car is going at 40 meters per second and it traveled at the speed for 5 seconds. It traveled at the speed for 5 seconds. Now find out how far it went. What is the distance it traveled? So then you plug it into the formula. S equals d by t. Then it becomes d by 5. And you change the 5 over. 5 fours are 20. And then 1 0 is added. So d equals. So let's just side change again. D equals 200. And you must write the unit. So what will be the unit here? Meters. Why? Because the five has a unit, seconds, right? S. And then look at this. So it's basically m by s, right? Because this has a unit. So we are only considering units now. So m by s equals to d by s. So look at this. What if you side change? So if you side change the 5 over here, right? The s comes over here on the top, s gets multiplied, and then s gets multiplied here, multiplying both sides so they cancel out. Or you can also think about it in the terms of like taking the s and then side change so it becomes multiplied. So cancel, and this one cancels out. So what are you left with? The m, the meter only. So units, think about it only in the terms of units. What if you side change the units? Now this is the units also are going to change. So only 200 meters is the answer. And again, if you have only distance, let's just say I covered 100 meters in, let's just say 30 seconds. Okay, so S equals d by t. And I do not know my speed. They have told me to find out about my speed. So 100 divided by 30. So cross and 10 by 30, you can do the math. It will come out to some you know decimal. So now the units will be meters per second, because distance was in meters and then it was divided by time, which was in seconds. So meters per second would be the unit. Okay, speed formula done. Now, what is the average speed? Oh, yeah. V equals S by T. So what is V equals S by T? V basically means velocity and S is the displacement, right? This was distance and this will be displacement, a straight line as you have seen before, and divided by time. So the time is similar from this formula and this formula. The time is similar and speed is replaced by velocity and distance is replaced by S, which is displacement. Okay, next, recall the equation average speed. Okay, you have to use average speed. So this one, totally similar. One small change, speed becomes average speed, and in return, you have to use total distance by total time. So what does that mean? That basically means they're the same thing. Honestly, they're the same thing. And total time, total distance, whatever it means, you will just look at the graph, right? I think there was a graph here. So let me zoom in. So the graph here, right? Time is given in your graph and then distance is given. So you'll take the total time from here to here, from here to 9. And then the distance would be to 6 point, and then you'll plug in into the formula. I'll get back into it. Okay, so now once you start doing the question paper, this one will make sense a bit more. But remember this one and this one, right? Almost the same thing. So then number 4, define deceleration as change in velocity per unit time. Okay, so acceleration comes in. So we'll take a look at the notes before that. Speed, velocity. Okay. So general formula, average speed equals total distance by total time. Example, if a car travels 300 kilometers in 5 hours. Okay, 300 kilometers distance and 5 hours is the time. Its average speed equals 300 kilometer divided by 5 hours. So 60 kilometers every hour, average speed. So on average, you have to travel 60 kilometers every single hour of the 5 hours to reach the 300 kilometers. Then comes velocity. Velocity is the distance traveled in a unit time in a given direction. So again, given direction matters. Speed is the distance traveled in a unit time. So the distance does not, you know, have a particular direction it is in. It can be anything, any path long. The string can be very windy and whatnot. So key definition: velocity is the change in displacement per unit time. So S equals d by t, as you have seen, displacement by time. Velocity is the speed in a given direction. So again, one more point. I don't know why you need that. A body's velocity is uniform or constant if it moves in a steady speed in a straight line. Okay, one more point. We'll get to that. Velocity is not uniform if a body moves in a curved path. So not much to see in here. You can write down these notes and whatnot, but it's in the website. So You can just look at the website unless you do not have internet, and you have limited access to internet, then you can just write it down when you have access to internet. Okay, so acceleration, what is that? Is there a formula for acceleration? Change in velocity by time taken. Define acceleration as the change in velocity per unit time. Recall and use this equation. um yeah, so acceleration, what is that? Change in velocity by time taken. So velocity, we know now what that is. So you take the displacement from A to B, and then you find out how much time it took and use the formula V equals S by T, right? So velocity can change, right? Why would that change? So if you move from line A to line B, and let's just say from this point to this point, you went at a very high velocity, say 10 meters per second. This is velocity. And from this point to this point, you took you went 5 meters per second. And from this point to this point, you went 2 meters per second, right? The velocity is changing. So let's just draw everything equally. Okay, so the lines are now equal. So yeah, your velocity can change from time to time, right? And you know, these gaps in the middle, right? These gaps in the middle mean something. What does that mean? So from 10 meters, right? You travel from here to here at 10 meters. Then you change your velocity in this gap, right? In this gap length, you pushed in your brake and change your velocity from 10 to 5 in this gap length. So what does this gap length represent? Let's just say in a graph, right? And time is in the x-axis. So this is time, and the y-axis is your velocity. So v l o. Let's just say v e l o, velocity. And only in this split moment, what happens? So your velocity will be going downhill until it goes to 5. And then when it reaches 5, it will continue for a long time until it reaches here again. When you push your brakes again, and it goes from 5 to 2 meters per second. So your velocity change from this moment to this moment. This is where the change is happening. The velocity is decreasing as y is representing velocity. So then the time taken, right? Let's just say this is 0, and this will be, let's just say, 2 seconds in the y-axis. So then what was the time taken? 0, then 1, then 2. So time taken, t would be equals to 2 seconds. So acceleration formula needs to be used, and that would be is acceleration equals to change in velocity. That would be, how do you find the change? You take the starting initial and subtract the final one. So starting one would be v, and final one would be u. As in the formula, you will later see they will start using v minus u by t. Acha. Let's go into the notes. Let's go into the notes. Let's find acceleration. Let's see if they use the formula. Unfortunately, I cannot easily find it, so let's forget it. But in short, it will be, you know, this one, v and u, starting and final one. So v minus u by t. This is how you find out the change, right? What is the change? So you take the bigger one minus the smaller one, then you get what is the change or reduction from bigger to smaller one, right? How much is reduced, and divided by t. So a equals to v minus u. So v would be 10 minus 5 by time would be 2 seconds. So a would be 5 by 2. And what is the unit? meters per second square. Why? Because velocity is already in meters per second, right? So m by s, right? And it is divided by 1 more second. So divided by 1 more second, and then you can write it this way as division sign. You can put a multiple sign and then reciprocal this one. So 1 by s, and then the s and s will multiply. So m by s square. Easy calculation. So acceleration will always be in meters per second square. Do remember, this is using velocity, right? Anything that uses velocity in the calculation will also have a direction, as the base mm, unit that is used, velocity, also has a direction, right? So any base units that have directions, any bigger and bigger units you calculate with this will also have directions. So velocity can also be, acceleration can also be positive and negative. Keep that in mind. So now we have take a look at acceleration. That would mean what? Changing your speed, or changing your velocity, sorry. Speed and velocity, very interchangeable. You just have to remember the underlying fact that one has direction and one doesn't, but they can be interchanged very easily. So do not make that mistake when you actually do the calculations. So one more smaller way to represent this is acceleration equals to del v by del t. What is del? Del only means change. Del equals to change. Keep that in mind, because you will be seeing that a lot from now on. Del equals change. State what is meant by and describe examples of uniform acceleration and non-uniform acceleration. Okay, we have taken a look at acceleration, and now they're asking us what is uniform and non-uniform. So uniform, you can think of this word as constant and non-constant acceleration, right? So what is constant? Basically same, it does not change. So what is acceleration and what is constant acceleration? Again, we have to erase this. Okay, acceleration. What did we learn about acceleration? It means changing your speed, going from one speed, increasing, changing to another speed. So you were at 5 meters per second, velocity, speed, again interchangeable, and then you went to 10 meters per second. So the speed was changed. Remember, when you are changing your speed, the car itself, right, it's still going forward. You are going at 5 meters per second, so you are traveling 5 units 1 second. And then when you increase your speed to 6, you will be next second going 6 units in 1 second. Then when you go to 7, you will be going 7 units in 1 second, right? And at the end, you will see you will be going 10 units per second, very fast. So again, the car is moving forward, but it is going faster and faster. So the movement does not stop, and the movement is faster and faster. Now that we know about that, let's see what is constant acceleration and not constant acceleration. So in a graph, you can think about it this way. Constant acceleration will be anything that has a integer number. So let's just say 10 meters per second square, right? This is acceleration. So a equals to 10 meters per second square. So what does this even mean? Your speed is increasing 10 meters per second every second, right? So once you are at 10 meters, the next second, right, 1 second later, you will be at 20 meters per second. The next second, 30 meters per second. The car will be accelerating, going faster and faster, and it will be going 10 meters per second faster each second. So this is acceleration. How do you graph it? How do you graph it? Draw it. This will be time. This will be velocity. And what does it look like? You start at 10. It starts going upwards, right? Constant acceleration. Constant meaning straight line, meaning constantly increasing, right? Constant doesn't mean it will stay the exact same velocity. We are talking about acceleration being constant, not velocity. Keep that in mind. Acceleration constant meaning acceleration is change, so velocity will be constantly changing, constantly changing. So going up as a straight line. Once you stop accelerating, velocity goes flat. So velocity, let's just say, is at 100 ms. So the car keeps traveling forward at 100 meters per second. But the speed does not increase, doesn't decrease. This is constant acceleration, right? Constant slash uniform acceleration. Non-uniform acceleration. Let's see that one. Non-uniform means not constant. So the velocity graph. Let's just say the velocity was increasing, but it started increasing even faster and faster and faster, right? So let's just look at your average car, right? If you stick the brake or acceleration pedal very hard, right? The acceleration will change. First second, you will be accelerating at 10 meters per second square. Second or 2 seconds later, right? You'll be going, let's just say 22 meters per second square, right? That would mean what? Your speed will be increasing by 22 meters each second, each second. So this is non-uniform. And basically remember this, the line will be curved, right? This will be a curved line, will not be a straight line. Anything other than a straight line is non-uniform acceleration or not constant. So if the curve is going like this, it's going like this, it's going like this, right? Non-uniform. Does not matter how many bends it has. It if it's not a straight line, it's not uniform acceleration. Oh, okay. So non-uniform, uniform, we get that. Know that deceleration is a negative acceleration and use this in calculations. What is deceleration? Is a negative acceleration. So acceleration means increasing speed, right? If you're going in a car, right, you're going this way, you're accelerating this way, your speed is increasing this way. Okay. So let's just say now you want to decelerate. What does decelerate mean? So your car is going at 100 meters. Sorry, your car is going at 100 meters per second. You want to decrease the speed. So you apply deceleration. What is deceleration? A force to slow down the car, a force against the movement of the car. And let's just say you're trying to pull the car back with your hands and whatnot or anything, right? So the speed will start decreasing. And this also works exactly like acceleration. So let's just say you have deceleration or deceleration, right? Deceleration of 10 meters per second square. That would mean what? The speed is decreasing 10 meters each second. So then it will become 90 meters per second, then 80 meters per second, and so on until you reach zero, 0 meters per second. Then what happens? Then if you still apply the force backwards, right, the car will start moving backwards, but that is a whole different story. And if you're applying the brakes, then the brakes will just stop the car at zero. But if you're pushing the car backwards, then it will get pushed and it will go backwards. So this is deceleration. And as we have discussed before, acceleration is a vector. So direction matters, right? So CDI, direction matters. Why does or how does direction matter? We know why direction matters. So how does direction matter in acceleration? If you're accelerating towards the right, we take that as positive. Positive 10 meters per second. So let's erase this. Positive 10 meters per second square. And this is positive. So if you're going to the leftwards direction, this will be negative 10 squared acceleration, but negative. And in our car example, what did we see? The car was traveling here in this direction, but there was an opposing force, an opposing deceleration. Deceleration was 10 meters per second square. So if deceleration means you're accelerating in the opposite direction, and if you're going in the opposite direction, then what happens? It becomes negative. So negative acceleration is what they call deceleration, right? Remember that the- anytime, anywhere they mention deceleration, it is basically acceleration, and in the opposite direction, negative direction. And yeah, a lot of the times you will find acceleration is negative, depending on which direction you decide to take positive. If you take, left as positive, then obviously the right will be negative, and so on. Sketch, plot, and interpret distance, time, and speed time graphs. So, distance time graphs. I'll give you a shot. Let's read this. First of all, speed time graph. Speed time graph, very simple. So, y-axis will be s, which is for speed. Let's just fully write it. S not in displacement, speed. And this will be time. So, if a speed time graph is drawn like this, so going like this, what does this mean? So, this is a speed time graph for a car. For this car, let's just say the speed time graph starts at, it is starting at origin 0, which is time 0. At 0 seconds, the car is already moving at 10 meters per second. Then it goes up to increasing, like constantly increasing. So there is an acceleration, right? Acceleration, and it is constant acceleration. Why? Because the speed is increasing constantly in a straight line. Constant acceleration, and it reaches 20 meters per second speed, and then the speed decreases to, let's just say, 7 meters per second, and then the speed is constant. Here the speed is constant. As the speed does not increase, it does not decrease. The car is moving in a constant speed. Here again constant speed. After the car decreases its speed from 20 to 7, right? And then it moves in a straight line from here, straight line. Then there is uniform acceleration and non-uniform acceleration. So there's a curved acceleration and the speed increases. So then there's a curved deceleration for some time. The speed decreases. Both are non-uniform. And then there is uniform deceleration as the speed decreases, and it goes down to 0 at time 15 seconds. So this is how you normally draw a speed time graph, and this is what the speed time graph means. These shapes and whatnot. Okay. So when an object is at rest, right? When an object is at rest, the speed time graph will go like this. So it was moving, then the speed decreased and it hit 0. So then when it hits 0, it will stay here at 0, and then it will rise again if the question shows it will move. So from here to here, the speed was 0, meaning at rest. Speed 0 at rest. Remember, the speed 0 at rest. Speed 0 means at rest. Memorize that. Moving with constant speed. These normal lines, right? Moving with constant speed. Speed does not increase, decrease. This means constant, not changing. Moving with constant speed. We did that one. Accelerating. So here it is accelerating, constant, decelerating, constant. And when there's a curve, non-uniform acceleration, then deceleration. Oh, sorry. This one was for distance time graph. And we were studying speed time graph. So all this, but for the second one. So at rest, we have seen flat line, but at the bottom, right? Flat line, but at the very bottom, not here. Moving with constant speed, we have seen. So at here, meaning straight line, not at the bottom, it will not work. Only has to be at the stop. top or anywhere from the bottom. Just slightly above will do, like even here will do. It cannot touch the bottom. Moving with constant acceleration, so we have seen that one. Constant acceleration and then deceleration, and then non-uniform. As with changing acceleration, changing acceleration is this one. Constant speed, constant acceleration, changing acceleration, all have been now shown. State the acceleration of free fall g of an object near the surface of the earth is approximately constant and is approximately this 9.81 meters per second. Okay, so one random fact is inserted, which is acceleration of the earth. So let's go through the notes. Let's see if we missed anything. Velocity, things about velocity, speed, units are the same. Acceleration, key definition. Okay, okay. So here are some examples. You can see them. Try to see if you understand these and whatnot. Constant speed, it shows here. Speed is 5 from A to B. It does not change. Constant acceleration, it increases. Then variable acceleration. This one is constant, but this one is changing acceleration with curve shape. As you can see, the acceleration is slowly increasing. It is accelerating faster and faster. Then it starts to accelerate less and less and less until it stops accelerating. So now comes the gradient part. So the gradient of a speed time graph. Okay, speed time graph is this, and we'll get into distance time a bit later. So speed time graph, gradient. The gradient of a speed time graph represents the acceleration. What is the gradient? If you have add maths, you will easily know this formula: y2 minus y1, x2 minus x1. So if you take any 2 points from this line and then use this formula, any 2 points, and then x and y, you can try to search up for the add maths formula. I'm not going to completely explain it. It will take a lot more time. So the gradient, you need to know how to calculate the gradient by now. And yeah, the gradient of speed time graph gives acceleration, right? Why? Because basically it is calculating the change of velocity with the change in time. So del y by del x. For constant speed, the gradient is 0. Constant speed will mean basically that is a flat line, so gradient will be 0. For changing acceleration, the gradient changes, indicating changing acceleration. So as you can see, the points change, right? The gradient is changing here. As an object accelerates, if the speed increases and decelerates, and an object accelerates if the speed increases. Oh, and decelerates if the speed decreases with time. Yeah, that is just common sense. If your speed increases, acceleration. If your speed decreases, deceleration. Area under a speed time graph. So now we have to understand what does the area give us. So the area under the speed time graph gives us the distance, measures the distance traveled. The rule applies even if acceleration is non-constant. What do they mean? So basically, even if the line is carved like this, right, the area under here will be the distance, or the shaded area under the graph. This is the shaded area. So this is speed time. Now for distance time looks a bit different. So distance time at rest, let's just see. So this will be distance time So what if a car is at rest? Okay, let's now start with the rest one. Let's just start with distance time graph moving with constant speed. So in a distance time graph, not speed, this is not speed, distance. What if your car is moving with constant speed, right? Your distance will increase. So let's just say you are already a car. So let's just draw the scenario, like this is the starting point A and your car is here. Your car is here, your car is going towards B. So this will be point B. Sorry, here will be point B. So this will be a car. It has traveled some amount of distance. It needs to go a lot more. So the car is moving at constant speed. So as it is already a bit far from point A, it will start from here and constant speed, meaning the line will be like this, right? The distance is increasing constantly, 10 meters per second, 10 meters per second, then so on and so on. So moving with constant speed. Then what if the car stops? The speed is instantly decreased to zero. Then the line will go flat. Why? Because the distance is not increasing and not decreasing. Why is the distance not decreasing? Because the car is not going backwards. If you stop the car midway, you're not going backwards, are you? So the distance will not go down. It will stay in a flat line and time will keep increasing, increasing as long as you're stationary, as you're sitting. So now we can look at acceleration. What does acceleration mean? The speed will keep increasing and increasing. What happens when the speed increases? So increasing and increasing, it will. So you were first going, speed is constant. So first you cover 10 meters, only 10 meters. Then you go 10 meters more, you go to 20 meters, then 30 meters, right? What if your speed is increasing in the middle of all this? First, you go 10 meters, then you go 25 meters. So that already adds up to 15 meters travel total from going to 10, from 10 to 25. Then you go, let's just say 20 more meters, right? So 45 meters. So as your speed is increasing, each second you are traveling 15 meters. You are traveling 20 meters, then you will be going 25 meters, right? This distance is increasing and increasing each second. So the car will look like this. So the distance will keep increasing and increasing and then decelerating. So what happens when you're decelerating? Does the car move backwards? No. So the graph will not go down, it will go up. So when you're decelerating, let's just say your speed was 100, right? Your speed, then in the first second, 100 meters per second, let's just say your speed. So in the first second, you go 100 meters, then deceleration of 10 meters per second happens, meters per second square. So deceleration will give it a minus, as to say minus acceleration is also deceleration. Then you will be going 90 meters, then you will be going 80 until you go 0. So the car will look like this. It will go upwards, upwards, upwards. It will go the gradient will decrease. Here the gradient is increasing. The curve is getting steeper and steeper, and the curve is getting flatter and flatter in this side until it becomes stationary and at 0. So this is what happens at rest, moving, acceleration, and deceleration. For both distance time and speed time graph, we have shown. So let's see the notes. A few equations. First equation would be acceleration is given by v minus u by t. And if you rearrange, meaning if you take the t, side change it, and then becomes at, then side change the u to the other side, and v equals u plus at. So this will be a equation you can use to find out anything. So if you have the, let's just say, initial speed, and you need the, so this is the this will be initial speed, and let's just say you need the final speed, right? You have acceleration and time given, then you can use this equation. We will get back to this equation when we actually do question papers. Just keep in mind this equation exists. Second equation would be average speed. How do you find out the average speed? You take the speed of any 2 points in the graph and then divide them, right? To find out the average speed between these points. So for final minus initial, so in this graph, the average speed would be 0. But if you take from you know here to here, from here to here, I don't know. So then the average speed would be different. So again, we'll use this in the question paper. The normal formula for average speed is this, and if you combine this, which would be b u plus v by 2 equals to this one s by t. Both are giving average speed, right? So you can equate these two and you will get this one, and s equals b plus u by t into t, and this one you do not need. Genuinely, you do not need in all levels. You can still learn it if you want. Now we come into air resistance and free fall. What is free fall? What is air resistance? We'll get into it. In the air, a coin falls faster than a small piece of paper due to air resistance. True. Why? The coin is much dense, and density means it has a much smaller surface area. So the object will be smaller in size, and a piece of paper, it will be much bigger in size. So the surface area it will have will be pushing against a lot of air. And so in an atmosphere with air resistance, one falls faster, one falls slower. But in a vacuum, both fall at the same rate. In a vacuum, there is an experiment which shows the hammer and the feather falling at the same time. You can try to see that in YouTube if you want. Air resistance has a greater effect on light bodies compared to heavy bodies. So lighter objects will be affected by air resistance more. So if you drop a light object from a plane, it will get pushed back a lot of pushed back by air, and yeah, affected by it a lot. But if you drop something very very heavy, like something made out of metal, air resistance will not matter much. And here again, dense heavy object density matters. So air resistance is negligible for dense heavy objects at low speed. So negligible meaning it is non-existence, or basically zero. It is close to zero, or you can neglect it, or you can just ignore it. Neglect or ignore, same thing. For at low speeds only, keep that in mind. Very very low speeds. Acceleration of free fall. So now, acceleration of free fall, this is a very hard concept at first, but slowly you will understand it. All bodies falling freely under gravity accelerate uniformly if air resistance is negligible. What does that mean? All bodies falling freely under gravity. From a plane, if you jump, let's just say you are the box. If you jump, then falls freely under gravity, falling freely under gravity, accelerates uniformly. There's so if you jump and there's no air resistance, right? No air is pushing against you. You will be accelerating downwards at meters per second of 9.81, right? This is how many meters per second you will be accelerating. So 9.81 downwards, right? You'll be moving downwards and accelerating. So your speed will keep increasing and increasing. This uniform acceleration is called the acceleration of free fall, denoted by g. So no other force will act on you, only the force of gravity will accelerate you, right? Then it is called free fall, right? Anything except gravity, right? Even if air resistance is there, you're not in free fall. Remember, free fall only means the effect of gravity is acting on you. And this acceleration due to gravity is given a special constant, which is g. G equals 9.81 meters per second on average. So the velocity of free falling body increases by about 9.81, 9.8, let's just say, they threw away one decimal meters every second. Ball shot upwards with the velocity of 30 meters per second decelerates by 9.8 meters every second, reaching its highest point after 3 seconds. Let's see this. A ball is shot upwards, right? When it is moving upwards, gravity will pull it down with 9.8 meters per second acceleration. So the speed will keep increasing until the speed increases and it becomes zero. So when the speed becomes zero, the ball is stationary for a very brief moment until it falls back down, because the gravity is not going away, right? It will still accelerate you behind because it is basically pushing you downwards. So the ball will start moving downwards again, and the gravity will help you go faster and faster down, accelerating you. So remember this. When you're moving upwards, gravity will decelerate you. This will be negative, if you think about it, negative acceleration will decelerate you. Once you're going downwards, then it will be positive. It will be helping you. As an object falls, air resistance increases, reducing its acceleration. So as an object falls, what happens? Gravity will increase your speed, right? But air resistance will push against you and stop you from increasing your speed, thus reducing the effect of acceleration. So your speed will be increasing less and less each second. Remember this, acceleration means increasing your speed, right? So air resistance will stop you from increasing your speed. That basically means your speed will increase less and less until it doesn't increase anymore. This graph shows perfectly. So once you jump, your speed will start increasing very rapidly due to gravity. And once air resistance is pushing you backwards, the acceleration is getting lower and lower and lower until the acceleration is very low. And after a bit of time, the acceleration becomes zero. Why? Because the force of air is pushing against you and gravity is pulling you downwards, right? Both cancel each other out, right? As at this velocity, just once your velocity increases enough, right? What happens when your velocity is very high? You're moving through air very fast and the air particles hit you. So at a very high amount of velocity or speed, the air resistance is very high as you have to cut through the air. So remember the terms, right? The differentiating between the terms is very hard. Velocity, acceleration, displacement. And over one year, juggling between these terms, you will come to understand the nuances and whatnot. And this will basically become muscle memory. So at this point, the skydiver opens the parachute. Once the parachute is opened, the parachute opens upwards and it spreads. So basically, a lot of air resistance is acting on you, right? And then you will be moving, I don't know, very, very slowly, let's just say. The air resistance will not allow you to move this fast, right? The velocity is very high, and now the parachute is open, so your surface area is also very high. So a lot of air resistance is acting against you, and then this air resistance becomes greater than the effect of gravity. So you start accelerating upwards. Imagine this. You're moving downwards, you open the parachute. The instant you open the parachute, right, the surface area becomes very big. And there was the downward effect of gravity and the upward force of air resistance. So once you open the parachute, right, the air resistance becomes very, very big, denoted by the big arrow vector. So as you can see, it is much bigger than the gravity. So that means they will cancel each other out. After canceling, there is still a bit of air resistance force left. So you will be accelerating upwards for some time, meaning your speed will decrease, right? You are traveling downwards, right? You're traveling downwards and you're accelerating upwards. So basically deceleration or negative acceleration. And so your speed will decrease. Remember, you will still be traveling downwards, just your speed will increase a bit, decrease a bit, right? And as you can see here, the graph is showing the velocity will decrease. The velocity will decrease, but you will still travel downwards, fall downwards. And after some time, they cancel each other out again, the effect of gravity and the effect of air resistance. As your velocity decreases, the air resistance also decreases. And so after opening the parachute, this is all that happens. A lot of explanation, a lot of, you know, jumping hoops, but again, once you start doing question papers and whatnot, this will start to come very intuitive, and you just need to do one example in the question paper and you'll be fine. If any of this is a bit confusing, just rewind 5 seconds, listen again. You have to almost memorize it, then you can start understanding it. Memorize it, then understand it. Or if you understand it from the first time, then congratulations, good for you. So all this stuff is written here. If you want to read it, please do. I am not gonna bother. Pause the video and read it. I'll move to the syllabus. So this one, okay. So we already know this one, which is area under speed time graph will give you the distance. Calculate the acceleration from the gradient of a speed time graph. So gradient of a speed time graph gives us acceleration. Only one more thing left. Calculate speed from the gradient of a distance time graph. So if you have a distance time graph, and let's just say this is the line you have, right? This is the curve you have. What will the gradient? You take this point, you take this point, calculate the gradient. It will give you what? It will give you the speed. Okay. So, yep, this will give you the speed. Any more points left? No, not really. So, short recap. You know, this is where the short recap will start and we'll end it after that. Define speed as distance traveled per unit time. The speed will be 10 meters per second. Distance per unit time. And formula for speed is speed equals distance divided by time. You can use this formula to find out things about in a question, right? If let's just say distance and time is given, speed is not given, find out the speed, use the formula. And then comes velocity equals displacement by time. Displacement is a to b straight line, and distance is a curved line. It does not matter how long you take, how much of a winding path you take. If you go backwards, that still counts as distance, and if you go here, it still is valid. But displacement will be a straight line from A to B. And the direction matters, right? The direction matters. So if you're going here to here, the direction matters. And velocity is also basically speed, but with direction. So if you're moving this way, then this is your direction, and your velocity will be 20 meters per second. So direction and a magnitude or an integer value, size. average speed is total distance by total time is the same thing as speed equals distance by time. Just take the whole graph total time. Acceleration, right? Acceleration is the change in velocity or the change in speed even, right? Because they are interchangeable bit. So the change in speed by the total time taken to change that speed. Let's just say you're going from 50 to 100 ms, both are ms, and it took you 25 seconds, right? Find out the difference would be what? 50 meters per second is the speed you increased or change in velocity, and the time taken would be 25 seconds is divided by 2 and 2 meters per second square, because both 25 seconds and this is also seconds, so they both multiply, units multiply. Velocity, acceleration is again one more thing for acceleration equation. So non-uniform acceleration and deceleration. Let's draw a graph. This will be speed, this will be time, right? So straight line, uniform acceleration. Anything other than a straight line will be non-uniform acceleration. Anything curved, anything curving upwards, downwards, both at the same time, it does not matter. Anything other than a straight line, non-uniform. Sketch, plot, and interpret distance, time, and speed time graphs. So we have done it, and at rest meaning for distance time graph, right? At rest meaning straight line. Anywhere, it does not matter where. D by T, right? Straight line could be here, straight line could be here, here, here. But for speed time graph, at rest meaning only at the bottom, right? Only at the bottom, it is at rest. If it as the top, then it is not at rest. Speed has to be zero, just to hit the zero place. For distance time, moving with constant speed, what happens when in distance time graph moving with constant speed? The distance increases in a straight line. Accelerating meaning the car will go upwards and upwards. Decelerating, the car will go upwards, but the gradient will decrease. Here the gradient increasing, gradient decreasing until it flattens at speed zero. Determine Asha. Now speed time graph. Moving with constant speed. Moving with constant speed. Meaning straight line, not at the bottom. Here, here, anywhere, straight line. Fully parallel to the x-axis. Moving with constant acceleration. So speed time graph, constant acceleration. Speed will increase constant. Moving a changing acceleration, speed will increase this way. And if the speed is decreasing, it will decrease this way. So it does not matter how much it happens or bends. Anything other than straight line is changing acceleration. And the acceleration due to gravity, we looked at that. If you are falling from any high place, gravity will accelerate you downwards. Calculate the speed from the gradient of distance time. So basically, yeah, distance time graph. Look at the gradient of any 2 points. Distance time graph gradient gives you speed. And the area under speed time graph gives you what? Distance. Motion with constant speed or constant acceleration. Calculate the acceleration from the gradient of a speed time graph. So acceleration can be found out from what? Speed time. So distance time gradient gives you speed, and speed time gradient gives you what? Acceleration, right? Equal to ACC. So I guess that is all for today. We covered chapter 1.2, the whole of chapter 1.2. And In the next video, we will try to cover chapter 1.3. I hope chapter 1.3 is not that big, so I don't know. If we can finish this one, we might try to go into chapter 1.4 too. So yeah, let's see what happens, and that will be all for today. Goodbye.